So with what I have here, this is just the homework that I'm going to ask you to do, and I do want you to see all of these steps. Oh, let me go ahead and fix this typo. That is not find dx and do, it's du and dx. All right, there we go. That's better. Rewrite the integral in terms of u, and this is really important. If it's a definite integral, when you do this, you absolutely also have to include those limits of integration. That's part one that a lot of people make an error with this. They do everything else, but they don't change those limits. And then finally, at the very end, replace u with g of x so that the antiderivative is in terms of x. The u portion is just to go ahead and get started with how to integrate. All right, so the first one we're going to go ahead and look at is this. It's the integral of x times the square root of 4x plus 1 dx. The inside portion underneath our square root is what we're going to go ahead and start with. And that tells me that u is equal to 4x plus 1. I take the derivative of that, so du dx is just equal to 4x. du is equal to 4x dx, and therefore dx is equal to du over 4x. So the steps that I need to go ahead and see this, I just need to make sure you have u. I need to know what du dx is. Absolutely have to have those pieces inside there. The other two you don't necessarily have to write out if you don't want to. I do believe it helps with substitution with this. All right, now let's go ahead and replace this, and you're going to see something interesting. If I do this, I now have the integral of x. I'm going to turn... Yeah, thanks, Redler. Yeah, sorry about that. So what happened is you're going to see I was thinking about the fact that I have this x inside here that we have to deal with, and therefore my hand decided to write what my brain was thinking as I was explaining something else. Because what you have inside here, I can replace this u, and that u now becomes, this is u to the 1/2 power. I can go ahead and replace dx, and dx is du over 4, right? But the big problem that I have here is this. Now, that's x. I can't pull that out. That is not a constant. So what do I do with the x? And go back and solve for x. And I get the fact that I know that x is equal to u minus 1 all over 4. Put that back in, and now I have that the integral is u minus 1 over 4 times u to the 1/2 times du. We could put that 1/4 there as well. So if I go through and take that out, that gives me 1 over 16 times the integral of u minus 1 times u to the 1/2 du. Now remember, you did a great job with this in section 4.1 and 4.4. You have to go through and simplify this because we don't have any kind of rule that allows us to do this when we have a product inside the integral. So I have to just leave that as 1 over 16 times the integral of u. And remember, this is just 2 over 2. So that gives me u to the 3/2 minus u to the 1/2 du. All right, so I just go ahead and finish it and I integrate that. One thing about notation, there is I think there's one or two of you that did this on your homework. So be very careful. After you do the integral, this integral symbol, and you use the power rule, this symbol goes away. So make sure that you take this off after you go through and do the integration. The 1/16 stays outside, and then we're left with, that becomes u to the 5 halves, again, because I'm just adding 1 to both of them. And then I flip that reciprocal, and that becomes to the 2/5. Do the same thing with the next one, so that becomes to the 2/3, u to the 3 halves. Do not forget your constant. And then just go ahead and multiply this out. So then it's 1/40 u to the 5 halves minus 1/24 u to the 3 halves plus your constant. So make sure you write the final answer. I'm sorry, I said in terms of u, but we want to get rid of u, and we have to write the final answer in terms of x, and we know that u is equal to 4x plus 1 from above, so make sure you plug that back in. So you should get 1/40 times 4x plus 1 to the 5 halves minus 1/24 4x plus 1 to the 3 halves plus your constant. And that would be the final answer for that. When you go through and decide what part your u wants to be your inside part of the function. So we're just going to go ahead and let u equal x plus 4. And knowing we need it later, I'm just going to also go ahead and say that I know x is then going to equal u minus 4. I'll have to substitute both of those. And this one is kind of nice because du is over dx is just equal to 1, which means that du is equal to dx. So again, I just went ahead and substituted in for u and x, and then I went ahead and multiplied out the numerator. Now everything is in terms of u. Unfortunately, though, that's not where we have to leave it, because this is 2u minus 7 all over u to the 1/2. So we have to break this fraction up, and we are left with 2u over u to the 1/2 minus 7 over u to the 1/2. du. Now I go ahead and break that up and simplify those exponents. So when I do that, I am left with something I can now integrate. Now I have the integral of 2u to the 1/2 minus 7u to the negative 1/2 du. Going through and using the power rule. And again, once you use this step, your integral piece goes away. So now all I'm left with here is, this is 2 times 2/3 u to the 3 halves. And again, sorry guys, you're just adding 1 to both of these, but the 1 is in the form of 2 over 2, which gives me, for the first fraction, that gives me 3 halves. And then I flip when I divide by a fraction, I flip it. Same thing over here. Only this is a negative 1/2 plus that, which would give me a positive 1/2. So now I'm gone through and left with minus 7 times 2 over 1 u to the 1/2 plus c. Now, like I said, it's one of those things that I see it's really, really common is you have to remember to go back and finish this question because the question I want in terms of x. And that's probably the most common mistake that I see. So we go back to the very beginning and we know that u was equal to x plus 4, and then substitute all of that back in and simplify it. So that just becomes 4/3 x plus 4 to the 3/2 minus 14 x plus 4 to the 1/2 plus my constant term.